In this example, we're asked to use the diagram shown to find the value of x and round our answer to the nearest hundredth. Notice, however, that our right triangle is positioned differently than in the previous examples. We're given a 40-degree angle, but it's more difficult to determine if the sides with given lengths of x and 4 represent opposite, adjacent, or hypotenuse relative to our given angle. Remember that the hypotenuse is always the side opposite the right angle, so our hypotenuse must be the side with a length of 4. This means that the side with a length of x is either the opposite or adjacent side. Since the side opposite the 40-degree angle is the unmarked side of the figure, then the side with a length of x must be the side adjacent to the 40-degree angle. Be very careful when setting up the ratio when the triangle has been rotated like it is here. So we're given that the side adjacent to the 40-degree angle has a length of x, and the hypotenuse of the triangle has a length of 4. And remember that cosine equals adjacent over hypotenuse. So we can set up the equation cosine of 40 degrees equals x over 4. Now, solving for x, we multiply both sides of the equation by 4. On the right side, the 4's cancel, and we're left with x. And on the left side, we have 4 times the cosine of 40 degrees. Now, if you're using a scientific calculator, you'll type 40 cosine times 4 equals to find the value of x. And if you're using a graphing calculator, you'll type 4 times cosine 40, enter, to find the value of x. Either way, we find that 3.06417 equals x. And rounding to the nearest hundredth, 3.06 equals x. The title of this unit, Trigonometry, is Greek for triangle measurement. 3 of the most basic ideas in trigonometry are the sine, cosine, and tangent ratios. The sine, cosine, and tangent ratios can be defined as follows. In right triangle ABC, the sine of angle A is equal to the ratio of the length of the side opposite angle A to the length of the hypotenuse. So, in right triangle ABC, the sine of angle A equals y over z. Notice that the abbreviation we use for sine is sin. Next, the cosine of angle A is equal to the ratio of the length of the side adjacent to angle A to the length of the hypotenuse. So, in right triangle ABC, the cosine of angle A equals x over z. Notice that the abbreviation we use for cosine is cos. And finally, the tangent of angle A is equal to the ratio of the length of the side opposite angle A to the length of the side adjacent to angle A. So, in right triangle ABC, the tangent of angle A equals y over x. Notice that the abbreviation we use for tangent is tan. An easy way to remember the sine, cosine, and tangent ratios is to use the word SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Neil sees a rocket at an angle of elevation of 11 degrees. If Neil is located 5 miles from the rocket's launch pad, how high is the rocket? Round your answer to the nearest hundredth. Let's start this problem by drawing a picture. We have Neil, who sees a rocket at an angle of elevation of 11 degrees. Notice that an angle of elevation is formed from the ground upward, where one side of the angle is the horizontal segment along the ground, and the other side of the angle is rotated 11 degrees upward from the ground. Now, to complete our picture, we're also given that Neil is 5 miles from the rocket's launch pad, so Neil is 5 miles from a point directly below the rocket. And we're asked to find the height of the rocket, so we can use x to represent its height. To find the value of x, notice that Neil, the launch pad, and the rocket form a right triangle. So, using the 11-degree angle, we're given that the side opposite the 11-degree angle has a length of x, and the side adjacent to the 11-degree angle has a length of 5. And remember that tangent equals opposite over adjacent. So we can set up the equation, the tangent of 11 degrees equals x over 5. Solving for x, we multiply both sides of the equation by 5. On the right side, the 5's cancel, and we're left with x. And on the left side, we have 5 times the tangent of 11 degrees. Now, plugging this into our calculator and rounding to the nearest hundredth gives us 0.97 equals x. So the height of the rocket is 0.97 miles.